we've got a more powerful voice cloning option, open source, using Coqui and Bark. So we're going to learn in this video how to run this web application, which has been very kindly put out by Sylvain Filoni. And Sylvain has kindly put out this Hugging Face Spaces, which I'm going to show you how to run on Google Colab. But if you don't want to run it on Google Colab, you can just directly go here and click this link and then start running it, which is also something that I've credited at the top of the Colab notebook. So it's easier for you. But if you're like me, if you don't want to stand in queue or if you don't want to wait, and if you want to just run it whenever you want to be flexibly, then you can use this tutorial to run it on Google Colab. To start with, first of all, this is using two different libraries, primarily Coqui and Bark. And Coqui recently added Bark support inside Coqui. I'm not sure if it is supposed to be pronounced Coqui, so I'm calling it Coqui. So if it is wrong, please let me know in the comment section. So they've got this Bark integration. So this entire code is put out by Sylvain, and we are going to just simply use that Gradio and run it. Before we move forward, I would like to first show you the demo. So this is the input voice that I've got from Dr. Jordan B. Peterson.
You're trying to impress the people that are there, and you're trying to get them to like you. And so you maybe.
So this voice is what we are trying to replicate or duplicate or clone. And when I'm trying to duplicate the voice, I want to duplicate it with this text. So I'm just saying, "Hey Raja, Lama red pajama. Today was a very tiring day and I can't believe how it went, and I'm happy that it was not very bad." So if you listen to the output voice, you would notice that one, it takes a lot of pauses. Second, the voice modulation changes a lot within the voice in itself. And third, sometimes it adds unwanted noises to it. Despite all these things, this is a very, very impressive voice cloning that I've seen in the recent time. Like forget about 11 Labs and all these kind of paid solutions, proprietary solutions. In terms of open source solution, this is one of the most impressive solutions that I've seen. And probably that is also the issues that we highlighted before are the issues that we are already aware with Bark. So probably Bark could improve and then fix it ultimately. But this is a very impressive output. Let's listen to it.
Hi, Roger. Llama, red pajama. Today was a very tiring day, and I can't believe it how it went.
In the view.
Can't save. I'm happy that it was not very bad.
So as I said at the start, you could have noticed that it takes a lot of pauses. The voice modulation changes, and suddenly there are like some weird noises that are available because again, Bark is not like your typical TTS system. It has a lot of things inside it. But either way, this is super impressive. So I'm going to show you how to run this. First of all, this Google Colab notebook will be linked in the YouTube description just for free. You can directly click it and then get started with it. This Google Colab notebook runs on the GPU, the T4 machine, and it manages to run. Like I at least did 5 or 6 iterations before recording this video, and it managed to run everything properly. So we have got the code credited. Click this link if you want to use a web application without doing any of this code. The second thing is I've created a fork of this myself. So we're going to do a git clone of it. And after we do the git clone, we're going to enter into that folder. So we have got this folder. We're going to enter into this folder. After we enter into this folder, we are going to install all the requirements. So if you see the requirements.txt file, so it is the TTS, which is from Coqui, but Sylvain has got the own version, like a clone with some fix. And then Hugging Face transformers, Torch, SciPy, and PyDub. If you want to add Gradio, you can add Gradio here, but otherwise, if you can install this everything, pip install our requirements.txt, then install the Gradio here. So technically, Google Colab will tell you to restart the runtime. For me, at least personally, I didn't restart the runtime and it happened to work completely fine. So if you want to restart the runtime, you can restart it and come back and install again, but I wouldn't suggest you to do it. So after you install Gradio application, then all you have to do is do this Python app.py. And once you do that, it is going to take a lot of time. Like as you can see, it took about like 14-15 minutes. It is going to download a bunch of models first. So the installation of requirements.txt and the libraries don't take time. But once you run the code for the first time, like the app.py for the first time, it is going to take a lot of time in downloading models. It is going to download the TTS models. It is going to download Bark model, and it is going to download a bunch of other models. So after your app.py is done, once you open the web application and then do the first cloning, again, it is going to download a bunch of models, which is again going to take time. So first, Like I said, it is going to download the required models. It is going to give you the public URL for the Gradio application. You click the URL, go to the application, and then start the first voice cloning. Then again, it is going to download a bunch of models like the Hubert custom tokenizer and some PyTorch models it is going to download. After this is done, every other instance would be much faster than the first instance. This is like your typical cold start problem. So keep that in mind. When you do this for the first time, it is going to take a lot of time. When you do it for the second or third time, it is going to take lesser time. Another important factor, a lot of people that do not know about Google Colab. So all these things that you're doing, every time you open a Google Colab, you have to do this again. Unfortunately, you don't have any other choice. And if you want a choice, that is where paid GPU solutions come into picture. But with Google Colab, there is no state that you can freeze in. So you have to do this every time again and again. Once you run this again, like for example, in this case, I can say python app.py with the bang symbol, bang python app.py. Then it will again take a couple of minutes, but it will give me a public URL, which I can click, and then it will open an interface like this, and I can add the voice, and then I can start cloning it. Adding the voice is very simple. You have got the drop audio here button or click to upload. So you can either like get the audio clip like this, you can get it from your computer and then start adding it. So it requires at least a 20-second audio clip for like a good input, and wave file is preferred. So I've got like a wave file, the Jordan Peterson file that I just played at the start, or you can also record from the microphone. So if you want to record from the microphone, you can do that as well. I tested it with certain celebrity voices, and most of the times when I tested it with celebrity voices, it happened to do well. And you can try out these examples, and also you can pick some of these voice characters and try. Overall, this is an interesting solution, and the fact that Coqui and Bark has come together, this is quite amazing. Thanks to the Coqui team and Bark team, and once again thanks to Sylvain for this web application demo that we managed to run it on Google Colab. Click here, stop it, or click and select disconnect and delete runtime. Stop everything so that you're not using extra GPU from Google Colab notebook, so that you can use it whenever you want again. Thank you so much for watching. See you in another video.